When most people think about airports, they think about airplanes, passengers, luggage, and destinations. But airports are far more than transportation hubs. In reality, every major airport is a massive industrial system operating like a small city. Beneath the terminals, behind the runways, and beyond the gates lies a hidden world of power systems, fuel networks, water infrastructure, communications technology, transportation systems, and thousands of machines working together every second of every day. Millions of passengers move through airports annually without ever seeing the systems that make their journeys possible. Every aircraft departure depends on a vast network of infrastructure that must operate flawlessly. The airport is not simply a place where planes land and take off. It is one of the most complex engineering environments ever built. Today, we are going beneath the surface to explore the hidden systems behind airports and discover how emerging hydrogen and fuel cell technologies could become part of the future of aviation infrastructure. A modern airport functions very much like a city. Just as cities require electricity, water, fuel, communications, transportation, and security, airports depend on these same systems to operate safely and efficiently. Thousands of employees work across multiple facilities. Restaurants serve food. Retail stores operate continuously. Water is consumed and treated. Electricity powers everything from runway lights to baggage systems. Communication networks connect aircraft, passengers, security personnel, and operations teams. Airports must manage these resources 24 hours a day without interruption. Unlike many cities, however, airports have almost zero tolerance for failure. A power outage can ground flights. A communications disruption can create delays across entire regions. A fuel system failure can stop aircraft operations completely. Airports are essentially highly engineered cities optimized for one purpose: moving people and cargo safely around the world. Understanding airports begins with recognizing that every visible activity depends on invisible infrastructure. Electricity is the lifeblood of every airport. Without power, almost nothing functions. Runway lighting systems guide aircraft during takeoff and landing. Terminals require lighting, escalators, elevators, climate control, security systems, and passenger services. Air traffic control systems depend on continuous power to coordinate aircraft movement. Baggage systems rely on motors, scanners, and automation technologies. Behind these visible operations are substations, transformers, switchgear, backup generators, and distribution networks that ensure reliable energy delivery. Airports cannot afford prolonged outages. As a result, they often maintain multiple layers of redundancy. Grid connections provide primary power. Backup generators provide emergency power. Battery systems increasingly support critical loads. Looking forward, hydrogen fuel cells are emerging as a potential solution for long-duration backup power. Unlike diesel generators, fuel cells can produce electricity with low emissions, quiet operation, and high reliability. Airports around the world are evaluating how hydrogen could strengthen resilience while supporting sustainability goals. The future airport energy system may combine grid electricity, batteries, renewable energy, and hydrogen into a single integrated infrastructure platform. Every flight begins with fuel. Before passengers board, before engines start, and before aircraft push back from the gate, aviation fuel must travel through an extensive hidden network. Large storage tanks receive fuel deliveries from pipelines, ports, rail systems, or tanker trucks. The fuel is stored, tested, filtered, and monitored to ensure quality and safety. Pumps move fuel through underground pipeline systems to hydrant networks located across the airport. This infrastructure often operates entirely out of sight. Passengers see airplanes, but rarely the storage farms, filtration systems, control equipment, valves, and distribution pipelines that keep those aircraft flying. Safety is paramount because airports handle enormous quantities of fuel every day. As aviation explores decarbonization pathways, hydrogen may eventually join these fuel systems. Future airports could include hydrogen production facilities, storage tanks, liquefaction systems, and specialized fueling infrastructure alongside conventional aviation fuel. While this transition will take time, the airport fuel system is likely to become one of the most important areas of innovation in aviation. Airports operate hundreds, sometimes thousands of vehicles. These vehicles move baggage, transport passengers, deliver food, support maintenance activities, push aircraft away from gates, and transport cargo throughout the airport. Every flight depends on this fleet operating efficiently and reliably. Traditionally, most ground support equipment has been powered by diesel engines. However, airports are increasingly exploring alternatives. Electric vehicles are becoming common in certain applications, while hydrogen fuel cell technologies are gaining attention for heavier-duty operations requiring long operating hours and fast refueling. Hydrogen-powered baggage tractors, pushback vehicles, shuttle buses, and service trucks offer several potential advantages. They can operate with zero tailpipe emissions, maintain strong performance, and refuel quickly compared to large battery systems. Because airports operate in controlled environments with centralized fueling requirements, they provide an attractive location for hydrogen adoption. Many experts believe ground support equipment could become one of the earliest large-scale hydrogen applications within airport infrastructure. Every suitcase begins a hidden journey the moment it leaves the passenger. What appears to be a simple process is actually one of the most sophisticated logistics systems inside the airport. Bags move through miles of conveyor belts, scanning equipment, automated sorting systems, and security checkpoints. Sensors track each bag. Software determines its destination. Automated systems route luggage toward the correct aircraft. This process must occur rapidly and accurately. A mistake can result in delayed baggage, missed connections, and dissatisfied passengers. Airports invest heavily in automation to improve reliability and efficiency. The baggage system demonstrates an important principle found throughout airport infrastructure. Many of the most critical operations are invisible to passengers. People see the outcome but rarely see the systems that produce it. Airports succeed because thousands of hidden processes operate continuously behind the scenes. The baggage system is one of the clearest examples of this hidden engineering reality. If airports are cities, then operation centers are the brain. These facilities monitor and coordinate thousands of activities simultaneously. Operators track aircraft movements, passenger flows, baggage operations, energy consumption, weather conditions, transportation systems, and security activities in real time. Modern operations centers combine data from multiple systems into a unified view of airport performance. Advanced software helps operators identify problems before they become disruptions. Artificial intelligence and predictive analytics are increasingly being integrated into these environments to support decision-making. As airports become more complex, the importance of centralized coordination continues to grow. Future hydrogen infrastructure, fuel cell systems, energy storage assets, and renewable energy resources will also need to be integrated into these management platforms. The airport brain will play a central role in balancing operational efficiency, sustainability, reliability, and safety. Most airport infrastructure exists beyond public view. Beneath the terminals and runways lies an interconnected network of systems supporting every operation above ground. Water treatment facilities provide clean water. Power distribution systems deliver electricity throughout the airport. Data centers process information and communications. HVAC systems regulate indoor environments. Fuel systems supply aircraft and vehicles. Increasingly, hydrogen is being considered as another infrastructure layer within this hidden ecosystem. Hydrogen production systems, storage facilities, compression equipment, fuel cells, and distribution networks could become integrated components of future airports. The goal is not simply to add another technology. The goal is to strengthen resilience, reduce emissions, and create a more sustainable aviation ecosystem. The deeper we look beneath the surface, the more we realize that airports are not defined by airplanes. They are defined by infrastructure. Every airport generates wastewater. Restrooms, kitchens, maintenance facilities, cleaning operations, and stormwater runoff all contribute to the need for wastewater management. Specialized treatment systems collect, process, and clean water before it is discharged or reused. These facilities protect public health and environmental quality. Screens remove debris. Biological treatment processes break down contaminants. Clarification systems separate solids. Disinfection systems ensure water quality standards are met. Water management is becoming increasingly important as sustainability goals evolve. Airports are exploring water recycling, rainwater harvesting, and resource recovery technologies. These efforts align closely with hydrogen infrastructure because water is also a key input for electrolyzers used in green hydrogen production. Future airports may view water not only as a utility, but also as a strategic resource supporting energy generation and decarbonization initiatives. As airports pursue sustainability goals, energy infrastructure is evolving. Traditional airport power systems were designed primarily around grid electricity and diesel backup generation. Future systems may look very different. Hydrogen energy storage, fuel cells, renewable energy integration, battery systems, and advanced power management platforms could work together to create highly resilient energy networks. Fuel cells can provide clean backup power. Hydrogen storage can support long-duration energy needs. Renewable energy can reduce emissions. Intelligent control systems can optimize performance. The airport of the future may function as its own energy hub. Rather than simply consuming electricity, airports could generate, store, manage, and distribute energy across multiple technologies. This transformation would improve resilience while supporting the aviation industry's broader sustainability objectives. The story of airports is really the story of systems. Every terminal, runway, aircraft movement, and passenger journey depends on hidden infrastructure working together seamlessly. The same principle applies across the hydrogen industry. Behind every electrolyzer, compressor, storage tank, fueling station, fuel cell, and pipeline lies a network of machines, components, engineering decisions, and industrial systems. If you want to explore these systems in greater detail, generate project schematics, understand how hydrogen infrastructure works, and follow the technologies shaping the future of energy, visit H2 Hub by Renee Energy. Because the more we understand the systems behind our world, the better we understand the future being built around us. Follow the system, understand the world.